Hello good people, I'm going to briefly explore how rates are related to ratios. Turns out that a rate is a ratio that compares two different quantities that usually have different units. Speed is a rate of distance per unit of time, for example 40 kilometers per hour. Density is a rate of mass per unit of volume, for example 2.26 grams per milliliter. And price is a rate of cost per item, for example dollars per amusingly shaped toy that might make your aunt smile. The neat thing about all of this, at least in my opinion, is that the units of a rate can be used to derive formulas. Let me take a closer look at the unit for speed, kilometers per hour. If I'm using kilometers, I'm measuring a distance. If I'm using hours, I'm measuring time. So the formula for speed is distance over time. In a similar fashion, if I look at the unit for density, grams per milliliter, I use grams when I measure mass, I use milliliters when I measure volume. And so the formula for density would be mass over volume. We can apply a similar approach to derive a formula for price. In this case, we have the dollar sign indicating the cost and some sort of object. And so the formula would be cost divided by number of objects. Let me look at two quick problems. What is the speed of a rainbow lorikeet that flies 160 kilometers in 3.5 hours? What are the two different quantities that are being compared here? We have distance and time. Or in terms of ratios, I could say that I have kilometers to hours. And in this case, it is 168 kilometers to 3.5 hours. According to the formula above, speed should be distance over time. And so in this case, that would be 168 kilometers divided by 3.5 hours. And unless my calculator is lying to me, that should be 48 kilometers per hour. In essence, this is telling me that my rainbow lorikeet will fly 48 kilometers every hour. If I was to write that as a ratio, it would be 48:1. Let me look at the second example. This time we are looking at the density of a compound that has a mass of 23.52 grams and that occupies a volume of 12.00 milliliters. The ratio relationship given here is grams to milliliters. In fact, it is 23.52:12.00. Using the formula, I can calculate the density, and it would be 23.52 grams divided by 12.00 milliliters. And this will give me 1.96 grams per milliliter. In terms of ratios, this is telling me that 1 milliliter of this compound will have a mass of 1.96. Alternatively, I could say that the mass to volume ratio is 1.96:1. That is all for now, and I will see you on the flip side.